Today we are going to discuss about the acids. So what are acids? Acid is a substance that produces hydrogen ion when placed in water. So acids are H plus releasing substances which are also called protic acids. So how we can detect whether some substance is acid or base? Their taste is sour. They react with metals to release hydrogen gas. They are corrosive. That means they react with the vessel in which they are stored and have a chemical formula that begins with H. Now question is, what are common acids that we are familiar with? One is acetic acid, which is used at home like vinegar. Citric acid, which is present in citric juices. Formic acid, which are released by ant when it bites us. Hydrochloric acid, which is released in our stomach. Sulfuric acid, which is known as king of chemicals, and nitric acid. And next is bases. What are bases? Bases are the substances that release OH negative ions when dissolved in solution or in water. Now the properties of bases: they taste bitter, feel slippery like soap, are corrosive. They also react with the vessel in which they are stored and have a chemical formula that ends with OH. That means NaOH, KOH, etc. What are common bases? Ammonia, which is used in cleaners and fertilizers. Sodium hydroxide, used in soaps and drain cleaners. Magnesium hydroxide, an ingredient found in antacids. So today we are going to define indicators. First of all, indicators are the substances which change their color to tell the nature of a solution, whether they are acidic, whether they are basic, or whether they are neutral in nature. So I am having some indicators with me, like litmus, like methyl orange, like phenolphthalein. It will indicate the nature of different type of solutions by changing their color. So first of all, I am using blue litmus. You should note what are acids. Acids are substances which release H1 positive ions when dissolved in solutions. And how will you check these solutions are acidic or basic? Acids change the color of blue litmus into red. So I am having some acids, I am having blue litmus paper. So let's check whether it is changing blue litmus into red or not. So I am using blue litmus paper and some of acids are there. This is dilute sulfuric acid. So let us check. It is in front of you. Just see. The blue litmus color is changed into red. That means H2SO4 is an acid. And next one acid is HCl. I'm using HCl to detect its nature, whether it is acidic, basic, or neutral, and same blue litmus. So you can check the color of blue litmus paper is changed into red. That means HCl is also an acid. Now third one. Third acid is acetic acid, which is used at home like vinegar, CH3COOH. So let us check whether it is acidic, basic, or neutral. Same process. Let us see. The acidic acid changed the color of blue litmus into red. That means CH3COOH is also an acid. So these were indicators. These acids do not change the color of red litmus. Let us check. Yes, I am using red litmus paper and I am using HCl. So you can see the color of red litmus remained as such. So that means it cannot change the color of red litmus paper. So to find the nature of an acid or base, we can use litmus paper. So I have used both litmus papers, blue and red, to check whether they are acids. Now let us apply it on bases. So I am using ammonium hydroxide as a base and blue litmus to check whether it is acidic or basic. Just see. Ammonium hydroxide didn't change the color of blue litmus. That means ammonium hydroxide NH4OH is basic in nature. Red litmus paper. So it is ammonium hydroxide NH4OH solution. Just see. The color of red litmus paper is changed into blue. That means ammonium hydroxide is basic in nature. So I'm using phenolphthalein to check whether the solutions are acidic, basic or neutral. First of all, I should tell you that the phenolphthalein is colorless, and I am having it over here. You can see it. It do not impart any color to acidic solution, whereas it changes the color of basic solution to pink. So let us try. So I am using an acid like dilute sulfuric acid and phenolphthalein as an indicator. You can see the white color is formed, no specific color. So that means H2SO4 is an acid. So let's check the next one. Next is I should try a basic solution to prove that ammonium hydroxide is a base and phenolphthalein changes its color into pink. So just watch. Just see. What a nice color. So ammonium hydroxide is a base, H2SO4 is an acid. So if we mix H2SO4 and ammonium hydroxide, they neutralizes one another, and it is called neutralization reaction, in which an acid neutralizes a base to form salt and water and neutral solution, we can say that. So let us mix sulfuric acid in this solution. When ammonium hydroxide is completely neutralized by an acid, so the color of this pink solution will be changed into white color. So let us try. You can see this, the color has been changed. So let us mix again ammonium hydroxide. Ammonium hydroxide will change the excess of sulfuric acid in the solution. When all the sulfuric acid is neutralized, then the color will remain same as it was in previous case, like pink color. So you can see when ammonium hydroxide a base, it neutralized the sulfuric acid, so the color of phenolphthalein reappeared. So that means the solution is now basic in nature. If we mix again H2SO4, same disappearance of pink color. Just check that. So these are indicators. So our next experiment is burning of magnesium ribbon. You can see that there is white layer of magnesium oxide over magnesium ribbon. So it can be burned as such, but the burning will not be smooth. So let's try. Just see. The compound form will be magnesium oxide, MgO. So it is a combination of magnesium ribbon to form magnesium oxide, and magnesium oxide is metal oxide, and metal oxides are basic in nature. So next I am going to check what happens when a metal react with an acid, a reactive metal. So I am using this zinc granule. So I am putting it in test tube and I am using an acid, any acid you can use. I am using sulfuric acid, dilute sulfuric acid. So as you can see, when zinc reacts with H2SO4 sulfuric acid, a huge evolution of hydrogen gas. If we smell it, it is not having any smell. So hydrogen is odorless, colorless gas. And just see what is going on. And the reaction is, I will write it on the board. And one more thing, if we touch it, the test tube is high in temperature. So that means when zinc reacts with, when any metal, any reactive metal reacts with acid, the reaction is exothermic reaction. I am going to write the reaction. What is going on here? Zinc plus H2SO4. Zinc is more reactive, so it replaces hydrogen and forms zinc sulfate and releases hydrogen gas. Next, I am going to demonstrate what happens when zinc or any other reactive metal reacts with copper sulfate solution. Copper is less reactive as compared to zinc, as you have studied in the reactivity series. So I am having copper sulfate solution which is blue in color. So I am using zinc granules. So zinc is more reactive as compared to copper. It will displace slowly copper and form zinc sulfate, and copper is replaced, forming as a copper metal. So we have to put it for some time. So I will give you its look after some time. The color of blue solution of copper sulfate will be disappeared, and a colorless solution will be formed, as the solutions of zinc sulfate are colorless. So I will write the reaction what is happening in this solution. It is zinc plus copper sulfate, as zinc is more reactive as compared to copper, and zinc sulfate and copper metal is formed. It is called displacement reaction. So many more reactions we can demonstrate. These were a few reactions, so you can also try in the lab in the assistance of your class teacher. Thank you very much. Thank you.